Hello everyone, my name is Akshat Shukla and today we are discussing about latest geomechanical problem of underground and opencast mining. This is a part of my assignment of geomechanical lab which is held under the guidance of Professor Singham Jayantu of NIT Rourkela. So what is geomechanics? Geomechanics is a theoretical and applied science of mechanical behavior of geological material. In mining, it is basically related to rock, determining rock properties which can be used in mining operations. Now moving on to the usefulness of this geomechanics. As we know, geomechanics is the heart of mining industry, or we can say mining is not even possible without geomechanics or rock mechanics. Geomechanics focus on improving the mine safety through fundamental principle of rock mechanics, and it is also helpful in solving the various problems faced in mining industry. The key area of expertise include developing and improving ground support technology, ground control which include pillar design, rock support design, rock mass classification, and problems like rock bust, coal works, etc. And geomechanics is also useful in advanced visualization, the use of virtual reality technology as a tool for a systematic approach to understand seismicity. It is also helpful in predicting mine subsidence, and it is also useful in numerical modeling. So now moving on to the latest problems, geomechanical problems faced by the underground or open cast mining. As we know, mining is going deeper and deeper because the surface reserves are exploited, and so as we are going deeper, we are facing lot of problems related to geomechanics. So at first we have the anticipating of true rock behavior. It is a primary geomechanical challenge. Fundamental of understanding rock behavior is to carefully observe and then interpret field evidences. It has been found that the spalling or the brittle failure often dominates over the shear failure, and this process is highly dependent on the rock confinement. So basically, the thing we study in our class, the formula tau is equals to C plus sigma and tan phi, where tau is the shear stress, C is the cohesion, tan phi, where phi is the friction angle, and sigma is the normal reaction. This everyone studies in geomechanics, and we've solved a lot of problems with this formula. But in actual life, this is not valid in every situation inside the mine. So this is a major problem of geomechanics. So moving on to the next, the focus or stresses acting in the large volume of rock mass are generally unknown and are subjected to variations. However, the point measurement of the rocks is possible. The strength of the rock mass is not known well. It is difficult to measure large volume of rocks, and large scale rock testing or it is difficult and expensive also. Also, the time dependency behavior of rock is not well known. For estimating rock mass strength for laboratory purpose, for laboratory from laboratory properties and slope stability design is also a problem of concern. Last year summer, I visited GDK11 incline SCCL, which is in Ramagundam, Telangana. I observed there the major problem they are facing during mining is in blasting gallery, which is carried out in seam 3. The problem is the unpredictable failure of GOF, and they are also failing other problems that extend like extensive load at the junction, which they are solving by different methods like using tails and load cell, etc. Another major concern in underground mine is to work in contiguous seam. The roof and floor stability of the sections are major concern, and some mines are trying out methods like underpinning with cement, etc. Now moving to open cast mining. As we all know, open cast mining has some advantage over underground mining in terms of ventilation and better transport. Still, there are many geomechanical problems. With the increase in the demand of coal and minerals, heavy machineries are used in open cast mining, which requires high face size and high slope, which creates problems related to slope stability. Recently, accident occurred in OPC 1 Ramagundam SCCL during blasting operations. So, proper blasting designing is also a major issue. Design of slope and dump in open cast mining is still a major concern. Working near water bodies weakens the rock and which cause inundation in the mine, which led to huge destruction. Now moving on to some accident due to these problems. In 21st century, there are some accident. First at the Quadi, 10 fatalities, and which is due to the open cast failure of OC benches or the open cast benches. And the benches falls and people they are trapped inside the overburden. At Bagdi in 2001, 29 people died due to inundation. Durgapur 2001, 6 people died due to collapse of parting. In 2003, Godavari Khani 7 LEP, 17 people died due to inundation. GDK 811, GDK 8A in 2003, 10 people died due to roof fall. And at the last we have Central Sundra in 2005, 14 people died again due to inundation. Now moving on to the recent technologies or the recent development in the field of mining. At first we have robotics. The application of robotics technology is limited in the field of mining, but nowadays robotics based on the artificial intelligence can perform variety of tasks like drilling, blasting, loading, haulage, bolting and ore sampling, etc. At second we have the Internet of Things. Internet of Things, an emerging networking technology based on convergence of wireless technologies, micro, electromechanical systems and internet, can possibly transform the mining industry by creating new ways of maintaining mine safety and productivity. It basically involves use of sensors which are placed in the mines, and it can perform variety of functions. Next we have airborne gravity gradiometer technology for mineral exploration. As we know, mineral exploration is very difficult and expensive task. The University of Western Australia, in collaboration with Rio Tinto, has developed this method, which is known as VKI airborne gravity gradiometer, and this is a very useful technology. Next we have automated drilling. Automated or tail operated drilling solution can ensure mining personal safety and improve efficiency during surface mine operations. And next we have effective tunneling and boring system. As we know, it is the basic requirement of mining, and it is a typical need for a mine to have good shaft so that the mining operation can be performed. The other technologies include 3D imaging technology. 3D imaging technology have transformed the exploration of large minerals and continue to hold from with a number of emerging technologies. Here we use seismic survey to study the area, which is very useful in exploration. And another technologies are autonomous haulage, plasma technology for increasing precious metal yield, copper eating bacteria, remote operation and monitoring center. Now we move to the usefulness of geomechanics course. Geomechanics course is quite useful for all students to understand the various geomechanical problems and thereby deal with the present day problems which are faced in the mining industry. I would like to thank Professor Singham Gentu for the great concern and guidance throughout the course. The main highlights of the courses are the aggregate value, crushing value is a numerical index of strength, and this property can be used for the construction of roads so that they can bear the continuous load of the dumpers and heavy machines. Aggregate impact value help us to determine the impact strength of a material, which is a relative measure of the resistance of a material to bear shocks, which can be used in the pillar designing and support system. And loss abrasion test is used to find out the percentage wear due to resistance, rubbing or the other accession which is faced by a mine or haulage road. This property is used to design and proper haulage road. Flat jack method, it is used to determine the in-situ stress in the rock specimen. It can be used in designing of support system in underground. Brill hardness test and rebound hammer test are used to determine the hardness of the specimen. Rebound hammer is has an advantage as it can be used anywhere in the mine. It is very simple and easy to use. Proctor compression establishes a laboratory procedure to define the moisture density relation of compacted soil. There are other experiments such as measurement of ground vibration using minimate and minimate pulse.